Virtual Local Area Networks, VLANs, help improve network security, organization, and performance by keeping traffic separated and easier to manage. In a smaller network, there typically isn't a lot of change in just a few VLANs. For this type of network, manual setup and management of VLANs work fine. However, in larger and more complex networks, manually managing VLANs can become overwhelming. A good option for these types of networks is to use GARP VLAN Registration Protocol, GVRP. GVRP lets switches communicate and update VLAN information automatically. This dynamic approach means your network can adapt quickly to business needs without the risk of human error slowing things down. In this episode of Cisco Tech Talk, I'll explain GVRP, a feature available on Catalyst 1300 switches. Next. I'll start with an example of how it works. Let's say you've created a new VLAN for the marketing department on a switch. With GVRP enabled, that switch can announce the new VLAN to the other switches using the protocol. The other switches listen for these announcements. Once notified, they can add the new VLAN to their own configuration without you having to log into each one separately. It's called dynamic VLAN propagation. It saves you time, reduces mistakes, and helps your network stay consistent as things change. GVRP uses something called GARP, which stands for Generic Attribute Registration Protocol. It's how the switches send and receive information about VLANs. GVRP focuses on VLAN IDs and which ports are members. Most modern switches have GVRP built in. Like the Catalyst 1300 switch, it's often turned off by default. To enable it, you simply turn it on globally for your network. Since dynamic VLAN creation can be enabled or disabled per interface, specify which ports should use GVRP. Keep in mind that GVRP is limited to layer 2 interfaces. It can't be configured to run on sub-interfaces either. GVRP requires two-way communication, so unidirectional link routing shouldn't be enabled on GVRP interfaces. GVRP works even if you have switches from different manufacturers. That's because it's based on an open standard, IEEE 802.1q. Once GVRP is set up, the switches handle the rest, sending and receiving VLAN updates behind the scenes. This helps ensure that your network is always up to date. It also reduces the risk of devices being isolated or unable to communicate because of the missing VLAN settings. It supports better security practices, since you can quickly create or remove VLANs as needed. By automating VLAN management, GVRP lets you focus on more important tasks, like planning for the future or troubleshooting real issues, instead of getting bogged down by repetitive configuration work. Of course, GVRP isn't a good fit for every situation. Some organizations prefer to keep manual control over every switch for tighter security, or because their network is unique. A few other important things to keep in mind when using GVRP. Port security works independently, but may limit the number of GVRP participants. Additional memory is required per GVRP-enabled port for storing configurations and states. Native VLAN tagging on 802.1q trunks may cause issues with GVRP if other participants cannot accept tagged GVRP PDUs. You should also note that there can be interoperability issues if you use Spanning Tree Protocol, EtherChannel, or other VLAN management or trunk negotiation protocols. That's a quick overview of GVRP and VLAN management, designed to make your life easier, save you time, reduce mistakes, and offer flexibility as your business grows. Thanks for watching. I'll see you next time.